Welcome to part 5 of the quadratic test solutions. This page deals with determining quadratic rules from given information. It's 3K in the textbook. Any mathematical relationship can be expressed in 3 ways. It could be expressed as a rule, could be expressed as a graph, could be expressed as a set of points or a table of values. Table of values, or that could also be like a set of points or key points. In Maths Methods, Unit 1 and 2 and 3 and 4, you need to be able to do all of these things. You need to be able to take a rule, turn it into a graph, take a rule, turn it into a table of values, take a table of values, turn it into a graph, take a table of values, find a rule, etc., etc., etc. This particular section of the course and of the test is dealing with taking a table of values or a set of values and finding a rule, or perhaps taking a graph. You could imagine that the information in these questions is on a graph, and then you take that information and you find a rule. So it's going that way. What we often say, going backwards, because it's not how you start out doing it. You start out taking the rule and drawing the graph. So this first example tells us that the parabola's got a turning point at 2, -3 and another point at 3, 6. You could imagine that that's on a graph. It would look something like this: a turning point at 2, -3 down there, another point at 3, 6 there. It's some sort of parabola. It turns at 2, -3, so it goes like that. We know it's like that. We know that's 2, -3. We know that's 3, 6. How can we find what the equation is? Well, it's in turning. We're given the turning point, so we can use the turning point form of a quadratic. Turning point form of a quadratic looks like this, where the turning point is found with the K and the H. Well, our turning point is 2 and -3, so we can put the values of the turning point, 2 and -3, into the turning point form. Now it's +2, so we will have -2 in the bracket, and it's gone down 3, so we will drop it 3 at the end. We leave a possibility for some dilation factor outside, because we don't know whether this polynomial's been made skinny or wider, or whether it's got a bigger number, a smaller number, or even maybe a negative number. It could be upside down, in which case the A would be negative. You're better off just leaving an A there and then subbing in the other point, finding out what that A value is. The other point we're given is 3, 6, so we're going to sub in 3, 6, that's x equals 3, y equals 6, into this equation we now have. 6 equals A times 3 minus 2 squared take 3. 6 equals A times 1 squared take 3. Add the 3 over. 6 and 3 equals A times 1 squared, which is just 1. We've now found out, therefore, that A equals 9, and now we know that the parabola is 9x minus 2 squared take 3. We have determined the quadratic rule from 2 pieces of given information. The first mark would have been for putting the turning point in to the turning point form. The second mark would have been for calculating the A value, or the dilation value. And the third mark would have been for providing the final full equation of that quadratic. The second example, slightly different, has 2 x-intercepts and another point. If I was to draw this graph, goes through -1, goes through 2, goes through 3, 6. Something like that. Don't need to get that perfect. -1, 2, 3, 6. It's not an appropriate graph for a test. The graph isn't part of the question. If it was, you'd have to have 2 naught and -1 naught there. Remember that. You'd have to do this. But I'm just doing a sketch to see what it looks like. Now, I've got x-intercepts, so this time I'm going to use the x-intercept form, which looks like this. Again, use an A for any unknown dilation factor, and 2 brackets for the 2 x-intercepts, 2 factors for the 2 x-intercepts. I have -1 and 2, so I'll sub them in. The -1 will be a +1 in the bracket, because we always you go opposite to the sign to get that x-intercept, and the +2 will be -2 in the bracket. Now, to find the missing dilation factor, to find a sub in 3, 6, x equals 3, y equals 6. So 6 equals a brackets 3 and 1 brackets 3 take 2. 6 equals a brackets 4 brackets 1. So 6 equals 4a, a equals 6 on 4 equals 3 on 2, and that's finished. The equation is 3 on 2 brackets x plus 1 brackets x minus 2. We just took that value for a and put it up there. We're finished. 1 mark for putting the x-intercepts, which are given in the questions, straight into the x-intercept form. 1 mark for subbing in the second point and finding the dilation factor. 1 mark for writing the final equation. That page was determining quadratic rules from given information, or it could be like this, from a graph, depending, and the exercise is 3K, should you wish to do any extra work on that. Thank you.